Hello students, in last video lecture we studied the concept of Lewis regarding acid and bases. Then after that we will discuss about dissociation constant for weak acid and weak bases, that is ionization of weak acid and weak bases. In this lecture we are going to start our new point, that is Ostwald dilution law. Ostwald dilution law. So in Ostwald, scientist Ostwald, in 1888 he proposed a law regarding acid and bases. So first of all we will derive the expression for acid, then after that base. Okay, Ostwald is consider the weak acid. Now our first law regarding acid, Ostwald dilution law for weak acid. So consider weak acid HA. I am already telling you Ostwald H means the substance which gives H plus ion in their solution. A means acid. Okay, it reversibly it gives ionization and HA which gives H plus and A minus. Okay, so if you want the little bit confusion of ionization and dissociation, some student asking me what is the difference between ionization and dissociation. So these are the equal concept regarding in ionization there is also separation of ions, and in dissociation it is also separation of ions, that is cation and anion are separated. Cations and anions are separated. So how much what is the difference between then ionization and dissociation? So ionization, it is generally happen in any substance. Ionization happens in any substance and the substance that do not conduct electricity. Dissociation takes place at any substance, but after dissociation it conduct electricity. Okay, this is the one basic difference for ionization and dissociation. Okay, many students asking me what is the difference between ionization and dissociation, because sometimes I am using the word ionization and sometimes I am using the word dissociation. So this is the equal, because related to I am using only separation of ions that way. So the basic difference is in ionization the substance that do not conduct electricity, and in dissociation that substance conduct electricity. This is the basic difference regarding ionization and dissociation. Okay, so now let us move to the derivation regarding Ostwald dilution law for weak acid and weak bases. So number first point we will give, consider 1 mole of HA. It dissociated it as H plus and A minus. So initial moles, I am writing here initial moles. So what is the initial moles? I am taking 1 mole of HA, because point to be noted that I am telling you the concept of degree of dissociation. Degree of dissociation means fraction of total number of moles that dissociate into its ion, called as degree of dissociation. I am taking 1 mole. How much mole will be dissociate? Because it is a weak electrolyte, and weak electrolyte always expressing in reversible arrow. Strong electrolyte contains only single arrow, because reversible reaction can't be possible in case of strong electrolyte like strong acid and strong bases. In case of weak electrolyte, reversible reaction is possible, because HA converted into H plus A minus combined together to form HA. So initial moles I am taking HA 1 mole. So what is the concentration, that is initial mole of cation and anion? It is 0 because dissociation process or reaction is not starting yet. Point to be remember, I am telling you the in chemical kinetics. So then after initial moles, the dissociation reaction takes place. Dissociation start out of 1 mole. How much amount of mole will be dissociated? How much amount of moles will be dissociated? So how much amount of moles at equilibrium? So I am writing here number of moles dissociated at equilibrium. How much amount of mole dissociated at equilibrium? So I am writing here in short form equilibrium. So understand it. So dissociation, after dissociation it is 1 minus alpha, because I am telling you the concept of degree of dissociation. 1 mole out of formula is given by alpha is equal to total number of mole dissociated divided by total number of moles. So alpha it is given by 1 पैकी किती मोल डिसोसिएट झाले. 1 मोल मी घेतलेला होता 100 रुपये होते, 50 रुपये खर्च केले, 100 वजा 50. 1 मोल घेतला 0.2 मोल डिसोसिएशन झालं. बरोबर. 1 minus alpha. Okay, and what is the value of H plus A minus? That is equal to alpha. Please remember that alpha chemical kinetics आठवा. रेट ऑफ कन्झम्पशन ऑफ रिएक्टंटला एक्स मानलेलं होतं, एक्स कमी झाले, रिएक्टंटचे म्हणजे प्रोडक्टचे एक्स वाढले ना, एक्स वाढले, ही एक्सच आहे ना थोडक्यात, फक्त आपण डिग्री ऑफ डिसोसिएशनचं रेट वापरलंय. बरोबर. हे कायनेटिक्स मुळे तुमच्या लक्षात येऊ शकते. सो इन दॅट वे इट इज अल्फा. ओके. देन व्हॉट इज द कॉन्सन्ट्रेशन ॲट इक्विलिब्रियम? कॉन्सन्ट्रेशन ॲट इक्विलिब्रियम. So I am writing in short form, so you must have to understand it is not equation, it is equilibrium. So what is the formula of concentration? Concentration means number of moles divided by volume. We have studied it earlier in 11th standard. Okay. So what is the concentration in that case? Concentration of equilibrium. C is equal to number of moles. That is number of moles. How? 1 minus alpha divided by volume, because formula of concentration is equal to N by V, number of moles upon volume. So number of moles, this is the number of moles for reactant divided by volume. So 1 minus alpha divided by V is equal to C, concentration. Okay. Then how? What is the formula regarding ions? That is alpha divided by V, because dissociation in product alpha divided by V, because general formula N by V, number of moles alpha for in case of product divided by V means volume. So here it is also alpha divided by V. This is the basic data to derive derivation regarding Ostwald dilution law for weak acid and weak bases. So you have to take a screenshot of this basic data. With this given data, I am deriving the expression regarding acid. Okay. So now this is our basic data, concentration at equilibrium. Point to be remember that this is the general formula for concentration. Okay. Now by applying law of mass action, I am writing again this reaction because there is no space to write. So by applying law of mass action, we derive what is law of mass action? C raised to C. Point to be remember, C raised to C into D raised to D divided by A raised to A and B raised to B. So in that case we have to add, not Kc is equal to, I am adding Kaa for acid. So product H plus, point to be remember, Kc is equal to C raised to C into D raised to D divided by A raised to A and B raised to B. Capital A, B, C, D are reactant and product, and small a, b, c, d are stoichiometric coefficients. So you will understand it more clearly. In bracket H plus and in bracket A minus divided by HA, product upon reactant. What is the reactant? Reactant is HA, product upon reactant. Okay, now this is the general formula for law of mass action. By using law of mass action we get this. Now point to be remembered that what is the value of H plus and A minus and HA? This is the concentration at equilibrium. The value of H plus A minus is alpha divided by V, and reactant is 1 minus alpha upon V, because this is our final equation. So we have to add these values into this equation and we get, so what is the value of H plus? That is alpha upon V, alpha divided by V, okay, into what is the value of A minus? Alpha divided by V, alpha divided by V, divided by what is the value of HA? What is the value of HA? 1 minus alpha divided by V, 1 minus alpha divided by V, 1 minus alpha divided by V. So I am erasing that. Now how it is converted in short form? So let us see. K is equal to, I think, alpha square divided by V square. You all already know what is the final equation for us. 1 minus alpha upon V, 1 minus alpha upon V. Okay, now I think cancel out V, 2V cancel out, then dividation sign is cancel out. So alpha square divided by 1 minus alpha into V. So this is our next formula. Ka is equal to, you will understand it more easily, this is basic mathematics. Alpha square divided by 1 minus alpha into V. This is the next step of this equation. Alpha square divided by 1 minus alpha into V. Basic math samajhte. Then what is our next step? So I am erasing that. Then after that, this is the next step. Then please focus to the 1 minus alpha. Please focus to the 1 minus alpha. 1 minus alpha indicates, point to be remember that 1 minus alpha indicates I am taking 1 mole. Okay, out of 1 mole, alpha, that is dissociated is, that is equal to 0.1 mole dissociated, or let us say 0.02 or 0.01 mole dissociated. Why? Because we are deriving the expression regarding, I am not taking example, deriving the expression regarding weak acid and weak base. I am deriving the expression regarding weak acid and weak base. So for understanding purpose I am taking more simply examples, but in reality out of 1 mole there is only 0.02 or 0.04, 0.06 mole dissociated. Okay, in case of strong electrolyte like this, that is strong acid and strong base are completely dissociated. Out of 1 mole, 1 mole dissociated. 1 minus 1, that is equal to 0. So we can't discuss here. In case of strong electrolyte, that is strong acid, strong base. But in case of weak electrolyte, that is weak acid and weak base, it dissociate partially. Partially means minor quantity. Out of 1 mole it dissociate 0.02, because let us consider that CH3COOH, which gives CH3COO minus plus H plus. Out of 1 mole it dissociated only 0.02, because this 0.02 CO minus, CH3CO minus and 0.02 H plus ion again combine to form acetic acid. The process must be continuous and process must be go on reversibly manner. it dissociated acetate ions and H plus ion and CH3CO minus ion combined to form acetic acid. म्हणजे होतं काय, एकापैकी 0.02 इतकंच डिसोसिएशन झालं. डिसोसिएशन झालं की परत हे कंबाईन होते आणि पुन्हा ऍसिडिक ऍसिड मिळते. म्हणजे ओव्हरऑल डिसोसिएशन माझं कमीच आहे. बघा ना तुम्ही, ओव्हरऑल डिसोसिएशन कमी. जरी असं मानलं मी एक मधलं 0.5-50% डिसोसिएशन झालं, पुन्हा हे 0.5 हे परत कंबाईन होते पुन्हा ऍसिडिक ऍसिड बनते, पुन्हा तिकडे डिसोसिएशन झालं. म्हणजे ओव्हरऑल डिसोसिएशनची जी व्हॅल्यू येणार आहे ना, यातल्या एक मधलं 0.5 डिसोसिएशन झालं, पण यातले पण काही मॉलिक्युल्स कंबाईन होणार आणि ऍसिडिक ऍसिड बनवणार. म्हणजे ओव्हरऑल डिसोसिएशन मला कमीच मिळणार. 0.01 मिळेल, 0.04 मिळेल, वॉट एव्हर. अलग लक्षात. त्यामुळे ओव्हरऑल डिसोसिएशन कमी मिळणार. सो दॅट इज द मिनिंग ऑफ अल्फा. त्यामुळं पुसलं वाटतं मी, ठीक आहे. सो नाउ 1 minus alpha. So 1 minus alpha, it is negligible. So we can't take in given equation. So our previous equation is K is equal to alpha square divided by 1 minus alpha into V. So 1 minus alpha, it is a small quantity. Small quantity. Hence it is equal to 1. Small quantity, it is equal to 1. Small quantity is negligible. I am just clearly say it is negligible. So we can't use in here because 1 minus alpha is deleted. Out of 1 mole there will be only overall dissociation 0.02. Hence it is negligible. So it is equal to 1. 1 into V, that is equal to V. Okay, 1 minus alpha, that is equal to 1 minus 1, let us say. It is equal to 0. So it is negligible quantity. Negligible. In short, it is negligible quantity. Okay. So 1 minus alpha, then 1 minus, let us say 0.02. So it is negligible. So what is our remaining point is K is equal to alpha square divided by V. K is equal to alpha square divided by V. So in that case, we have to derive the two formula. Point to be remember that if I am separating V, okay, if I am separating V, then how will what is our next step? 1 by V. K is equal to alpha square 1 by V. Alpha square 1 by V. So point to be remember that if I am taking only 1 mole of HA, I am only taking 1 mole of HA. So general formula concentration is equal to N by V. So I am putting the value of N is equal to 1 by V. C is equal to 1 by V, that is equal to concentration. I am taking 1 mole. General formula of concentration is N by V. So I am taking 1 mole ना, एक मोलच घेतले, 1 by V, म्हणजे शेवटी ते कॉन्सन्ट्रेशनच आहे. So our next formula is equal to Ka is equal to alpha square C. Ka is equal to alpha square C because 1 by V is equal to C. 1 by V is equal to C. Number of moles upon volume. General formula. Number of moles एक घेतले, एक भागिले V म्हणजे पण C झालं ना. This is the original formula regarding dissociation constant of weak acid and weak bases. So now this is our final step and one more step is remaining. So that is equal to, I am erasing that. So K is equal to alpha is equal to K is equal to alpha square 6. Then alpha is equal to under root K divided by C. K divided by C. So then regarding K, this is our first formula. Then formula number 2 regarding original equation, K is equal to alpha square divided by 1 minus alpha into V, that is equal to V. K is equal to alpha square V. So this is the formula. What is it mean by alpha? Alpha is equal to under root Ka into V. Under root Ka into V. This is the two formulas regarding Ostwald dilution law for weak acid. This is the two formulas regarding Ostwald dilution law for weak acid. Okay, so it indicates alpha means degree of dissociation. Alpha means degree of dissociation. So degree of dissociation is inversely proportional to square root of its concentration. Want to be remember that degree of dissociation is inversely proportional to square root of its concentration. Okay, and degree of dissociation is directly proportional to square root of its volume. Directly proportional to its volume. Okay, so this is the two statement and two formulas regarding Ostwald dilution law for weak acid. This is the derivation regarding only in case of weak acid, not strong acid, because strong acids are completely dissociated. So there is no derivation in case of strong acid. This is the rule and regulation and derivations regarding in case of weak acid, that is weak electrolyte, consists weak acid and weak bases. So this is the derivation regarding Ostwald dilution law for weak acid. I am telling you once again, alpha inversely proportional to square root of its concentration, directly proportional to its volume. Okay, this is the two formulae. You have to note down it carefully because there are number of numericals which is asking in board exam in that formulas, with the help of these formulas. Okay, hopefully you have to understand this Ostwald dilution law for weak acid. In next video lecture I am giving the expression for Ostwald dilution law for weak bases. I am giving you the one homework for you, that is you have to derive one derivation. So I am writing here derive the expression for Ostwald dilution law for weak acid CH3COOH. This is the homework for you. Because I am deriving the expression for general. I am general representing symbolic form of weak acid. I am deriving the expression for using symbolic form. So you have to derive the expression for Ostwald at same as like me, but you have to use weak acid, acetic acid. Okay, not HA, because this is the derivation I am expressing you, I am telling you, explaining you. So HA I am not, you have not able to take HA, you have to use weak acid. Okay, I am deriving the expression regarding HA. So you have to derive expression regarding acetic acid. Answer must be same for you and me. Okay, this is the homework for you. Hopefully you have understand Ostwald dilution law for weak acid. Okay, in next video lecture I am telling you the Ostwald dilution law for weak base. Okay, thank you.